All right, today we're diving deep into the technology that honestly holds our entire digital lives together. It's the memory that keeps our photos, our work, and pretty much everything else safe, even when the power is off.
I mean, have you ever really stopped to think about it? Your phone, that laptop on your desk, even that little USB stick you have somewhere, they're all holding just massive amounts of information without being constantly plugged in. How does that work? What's the magic that lets you keep every single one of your vacation photos safe and sound?
Well, it's not magic, but it's pretty close. The secret is this brilliant little piece of engineering called flash memory. It's really the unsung hero of our digital world, a special kind of storage that has totally changed how we handle data.
Okay, so what exactly is it? Well, the key word here is non-volatile. That's just a fancy way of saying it doesn't need power to remember things. Think about the RAM in your computer. The second you turn it off, poof, everything's gone. Flash memory is the opposite. It hangs onto that data, which is exactly why it's perfect for all the gadgets we carry around.
You know, this whole thing goes way back to 1980, when Dr. Fujio Masuoka invented it over at Toshiba. Fun fact, a colleague of his thought the way it erased data all at once was as fast as a camera's flash, and believe it or not, the name just stuck. By the late 80s, we had two different flavors, NAND and NOR, and that really set the stage for a tech showdown that would define computing for decades.
And this is where things get really interesting, because not all flash memory is the same. It's kind of like a tale of two different architectures, two completely different ways of thinking about storage, NAND versus NOR.
At its most basic level, the difference is all about the wiring. It's how the tiny little memory cells, the pockets that hold a 1 or a 0, are actually connected to each other. With NAND, they're strung together in a series, one after the other. With NOR, they each get their own connection, running side by side in parallel. And that one single design choice, it changes absolutely everything.
So let's talk about NAND first. Its series connection is just like links in a chain. This structure is incredibly efficient when it comes to space. Since you don't need a separate wire for every single cell, you can pack them in super tightly. And that right there is the secret to NAND's massive storage capacity.
NOR, on the other hand, is completely different. Think of it like the branches of a tree. Every single memory cell has its own direct path right back to the trunk. Now, this takes up more physical space for sure, but it gives NOR a huge advantage. You can grab any single piece of data almost instantly.
So you've got a chain that's built for packing in tons of data, and you've got a tree that's built for pure speed. This one difference leads to a massive showdown, really dictating everything from performance and cost to what each type of memory is actually good for.
All right, let's break this down. NAND's chain structure gives you huge capacity for a low cost, and it's great at writing big files. NOR is basically the opposite. It gives you blazing fast read speeds for plucking out small bits of information, and it's generally more reliable, partly because NAND is so dense it needs extra error checking code, or ECC. But the trade-off is that NOR has a much lower capacity, and it costs more for every bit of storage.
And you know, this quote just sums it up perfectly. NAND is for storing your stuff, all your photos, your music, your documents. NOR is for executing code, the actual instructions that make a device boot up and run.
Okay, so enough with the theory. Where do you actually find this stuff in your day-to-day life? Because trust me, you are interacting with both of these technologies all the time. You'll find NAND in pretty much anything that needs to hold a lot of data. The solid-state drive in your laptop, that USB drive, your phone storage, the memory card in your camera, yep, that is all NAND. Its whole job is to be a gigantic, affordable bucket for all of your files.
And then there's NOR. It's used in devices where speed and rock-solid reliability are everything. It holds the essential startup code, the BIOS, on your computer's motherboard. It runs the firmware in your Wi-Fi router. It controls critical systems in your car. These are all things that need to start instantly and run without a single hiccup, and that's what NOR is all about.
But here's the thing, and this is super clever, they're not always rivals. A lot of the time, they're actually teammates. Your smartphone is the perfect example. It uses a tiny bit of NOR flash to hold the initial boot up instructions so it can start up really fast. But then, it relies on a huge bank of NAND flash to store the operating system, all your apps, and of course, all your photos and videos. It's pretty amazing that this tiny little chip is the backbone of a massive global industry. So who are the big players? Who are the titans actually building these microscopic memory cells? Let's take a look.
So if you look at the NAND market around late 2025, it's pretty clear who's on top. It's dominated by just a handful of giants.
Samsung is leading the pack with a huge chunk of the market, followed by companies like SK Hynix. In fact, a very small number of companies control most of the world's flash memory production.
So let's name some names. You've got the South Korean powerhouses, Samsung and SK Hynix. From Japan, you have Kioxia, which is actually the direct descendant of the Toshiba memory division where this all started. Then there are the major American players like Western Digital and Micron, and China's YMTC is also becoming a really serious contender.
But, just making the chips is only one piece of the puzzle. How do they get from a massive factory into the billions of devices we use every day? That's where distributors come in, and they are absolutely crucial. A company like Unibetter, for instance, manages this huge global network of thousands of suppliers just to make sure the device makers get the exact parts they need, right when they need them.
And the pace of innovation here, it's just insane. To give you some perspective, in 2025, Samsung showed off a new chip with over 400 layers of memory cells stacked vertically, one on top of the other. That is like building a 400-story skyscraper on a piece of silicon the size of your fingernail. It's just incredible.
So there you have it. From the startup code in your car to the thousands of photos on your phone, it's this quiet partnership between NAND and NOR that makes our digital world tick. But with the amount of data we're creating just exploding every single day, it leaves you with a really big question. What comes next? And how is the next generation of memory going to change everything all over again?